Hi, everybody. This is SAAD for the SAAD Truth. If I were to ask you to name the greatest inventor of all time, who would that be? Take a second to think about it. I discuss all this in chapter 10 of The Consuming Instinct, and some of the people that I list as possible contenders, this is on page 281 of chapter 10 of The Consuming Instinct, maybe Gutenberg, uh, printing press, or maybe Thomas Edison, the light bulb, maybe the Wright brothers, first flight, Henry Ford, car assembly line, Benjamin Franklin, bifocal glasses, Charles Babbage, mechanical computer, Alexander Bell, telephone. Let me add a few others. Maybe you think it's Steve Jobs. Maybe you think it's the guys of Google. Maybe you think it's Bill Gates. But in any case, lock in your answers. Who is the greatest inventor of all time? Well, it's a trick question. The greatest inventor of all time is nature because of the endless, innumerable solutions that it has had time to tinker with and come up with optimal adaptive solutions based on all of the animals and organisms that have existed in the past and are now extinct, and certainly the ones that remain with us. And so there's a field of study which I discuss precisely in The Consuming Instinct called biomimicry. Here's the book, if you like, the Bible of that field. There's actually a biomimicry institute. The author is Janine Benyus. I'm not sure if I'm pronouncing her name correctly. You can go check it out. I'll put a link to the institute, and it's basically a field of study that's truly interdisciplinary in that you really work at the intersection of biology, right? The idea is to go to the natural world and look for solutions that nature has already found for us, and then try to mimic them, hence biomimicry. So it's at the intersection of new product design, of engineering, of biology, of sustainability, of certainly conservation. It's a wonderful argument to make that, look, if we don't want all of these wonderful solutions and innovations that nature has come up with to go extinct, then that's certainly a very powerful conservation message. So examples here, I wrote a few of these, but there are many others. A few examples of biomimicry that are now being used by humans. So the gecko's feet, for example, the gecko has this unbelievable ability to be able to, not fall off, not slide off some very, very slippery surfaces, precisely because the gecko has evolved these incredibly adhesive properties in its feet. And so now material scientists are trying to mimic that to try to come up with similar solutions. The nautilus shell, some of you might be familiar with that. The nautilus shell is a spiral shape, which ends up being a wonderful structure to use if you're trying to, for example, minimize energy waste. If you, let's say you're designing some sort of pump or fan system or air conditioning system where you don't want to lose a lot of the flow of air that is coming through that structure, well, a spiral shape is much better than the current shapes that we typically use that are much more linear in nature. The woodpecker's incredible ability to use its beak, face all incredible, impact, and still not have brain damage. Imagine what the NFL could do in designing helmets that could withstand the impact that this little woodpecker is able to withstand in burrowing these holes in trees. Once in a while, I actually see them come out here in the summer, and I'm amazed how these little creatures can do what they do with these incredibly strong trunks of trees. I certainly couldn't do it, and yet they're able to do it with their little beaks. So how do they do it, and how can we mimic it? Spider's silk. It turns out that spider silk is it's stronger than steel, and so can we synthesize spider silk, for example, in building better material for bulletproof vests? And finally, one of my favorite animals, if not my favorite one, our co-evolved animal, the dog. Well, the dog's nose turns out to be unbelievably more powerful in being able to detect certain cancers than even the most sophisticated of our uh, medical diagnostic equipment. So, for example, there's a study, I can't remember the reference, I'll try to look for it, but that looked at a dog's ability or dog's nose at detecting certainly skin cancer. Now that you might say, well, okay, that makes sense. I mean, skin cancer is on the outside of a body, but it turns out that a dog's nose is able to pick up internal cancers, say lung cancer, simply by smelling uh, people's actual breathing into a vat, and then they're able to detect whether a person is suffering from lung cancer or not. Not only that, if I remember correctly, the study in question, the dog's nose is able with equal accuracy to detect the cancer, irrespective of which state of metastasis it's at. So you would think, okay, sure, if it's at level 4, if it's stage 4, maybe now it has greater olfactory signature. But it turns out that even at the earliest stage, where the typical human equipment might not be able to detect it, well, the dog's nose is able to detect it. So biomimicry is a very, very exciting field because, as I said, it's a wonderful way for us to harness the greatest inventor of all time, basically nature, for our service. Here's an example of another book, by the way, Biophilic Design. So in designing, say, architectural solutions, how do you design buildings that adhere to our biophilic instinct? Biophilia is a term that E.O. Wilson, the Harvard biologist, most famously discussed. This is our innate love of nature. So how could we design buildings or spaces that adhere to some of these aesthetic, if not functional, preferences that we hold? I discussed this, I think, briefly in one of my previous SAAD Truth clips. I'll try to link up to it at the end of this chat. So there you have it, folks. If any of you are interested in biomimicry, I definitely suggest that you check out the book that I put up earlier, and also go visit the Biomimicry Institute. Really, really cool stuff. Hope you're having a good Sunday. Talk to you soon. Ciao.